All right, everybody, welcome to another Daily Space Weather. More compelling imagery, fascinating stuff going on. A coronal mass ejection happening as we did show prep yet again. And another C-class flare. Here's the sun at 171 angstroms from the SDO. I would note this area down here, you're going to see a bit of a prominence happening. And we've got it in some more wavelengths. We're going to focus on 171 and 304 angstroms today. Spectacular. Following a geomagnetic storm, which briefly kicked in last night, mainly because of magnetic fields. Here's a composite view. This is 304 and 171 angstroms together. Ionized helium and ionized iron. Here's a close-up of that prominence. And if anybody would like to place bets on whether or not that is a sunspot, please leave your wagers in the comments. Here's an even closer close-up. I'm going to let this one play through twice. Just spectacular imagery here from the Solar Dynamics Observatory. Radio flux is still only at 73. Sunspot number still at 0. Here's a one-year chart of those two data sets. The black line is the radio flux, 10.7 centimeter radio flux. And the red line is the sunspot number. So here's the CME that that struck, allegedly, and I'm not seeing a signal. Leave us a comment if you see a signal in this set of data. I'm not seeing it. So allegedly someplace on here, a coronal mass ejection struck, and it looks like a magnetic field struck. As you can see, this very strong BTBZ moment right here, where the scale expanded all the way up to 20 nanotesla, and the BZ was all the way at like negative 13 or something like that. That I definitely saw magnetic field orientation. As far as a coronal mass ejection strike, show me where that's showing up as a signal in the velocity, or the density, or the temperature for that matter. I'm just not seeing it. Anyway, this is the Space Weather Enthusiast dashboard. You can see there was a forecast for geomagnetic storms early this morning. Those showed up a little bit earlier than expected, more like late yesterday. As you can see here, the G1 geomagnetic storm, a KP of 6, was indeed achieved. Let's take a look at global seismicity real quick. Current levels are moderate. No major quakes over a 6 magnitude. There was a 5.8 at Vanuatu. Some Alaskan quakes, some Californian quakes. There was a 4.7 at the Philippines. Tonga saw a 4.3 at depth. Also Chile, Bolivia, around the border, 4.4 magnitude at 217 kilometers depth there. Solomon Islands saw a 5.3. Pakistan saw a 4.7. The Kuril Islands, south of Kamchatka, saw a 5.0. Tajikistan saw a deep quake. So again, no major quakes over the past 24. 5.1 at Tonga. Oh, here's a 4.3 at Carson, California, the location of one of the most important bicycle racing tracks in the country. The wooden velodrome at Carson, California likely felt that 4.3. Leave us a comment if you felt it. And continuing on to look at volcanoes, it looks like a little bit of a volcanic uptick here. Fagradalsfjall has resumed its activity, possibly informing us that there's going to be an uptick at Fagradalsfjall, a continuing uptick. Fagradalsfjall, the Icelandic volcano that transformed before our very eyes from a cinder cone into a shield volcano by filling up its entire crater valley and then some with lava. Karimsky exploding on the Kamchatka Peninsula, producing a 20,000-foot ash plume there. Suminosejima flight level 060, 6,000-foot ash plume over the Ryukyu Islands. Mount Ibu exploding, 8,000-foot ash plume over Halmahera, Indonesia. Semeru exploding, 13,000-foot ash plume over East Java, Indonesia. Mount Agung has been downgraded to a volcanic alert level of green. A continuous degassing activity continues at the summit vent, characterized by, quote, only, and, quote, venting of emissions of steam and gases. All right. Popocatépetl exploding, 20,000-foot ash plume over central Mexico. Nevado del Ruiz, no volcanic ash clouds observed. Don't assume it's not erupting. Revenador exploding, flight level 150, and Sabancaya, 27,000-foot ash plume as it explodes. That located in Peru. Please don't pole vault the caldera. Please do visit smashamash.com. Check out our links, such as the Smash Team. If you'd like to pick up exclusive merch, I'm actually wearing some now. Check it out. And this is exclusive for only paid-up annual memberships. So if you want a piece of merch like this, you can pay up for a whole year in advance. And thanks to all of our Smash Team members who indeed did. Here's a little tease of what goes on. And we've got 3 different tiers there. The top tier includes a paid-up option. There's a $2.99 and a $9.99 per month tier. Smashamash.com has the links, as well as to our merch shop. And there it is. It's spectacular. The print quality is beyond quality. And our top seller appears to be My Vaccination Status is None of Your Business. Next, looking at the GOES magnetometers. And we have some maneuvering happening by the spacecraft there. That's what these arc jet moments are. That's when their thrusters create plasma, possibly affecting the magnetometer readings. And check out the very high readings we saw here. Some very high readings there. Associated with coronal holes, I would say. Spaceweather.com saying that it's in the wake of a CME. I'm not seeing a signal there, but let's not harp on it. Let's just move on. Those are measured by the GOES 16 and GOES 17 in geosynchronous near equatorial orbits. Next, looking at the magnetism of the heliospheric current sheet. Earth is still solidly in a south pole current sheet. And it looks like we'll remain there for the foreseeable future. Some activity rising in the southeast may change things. We'll keep you posted. Here's the line of sight ecliptic plane field plot showing you 0 sunspots on the solar magnetogram there and the 3-dimensional view of the current sheet. Here's the line of sight coronal hole plot, and we do see a bit of a growth of these South Pole oriented coronal holes. As you can see there in the latest image, some well-defined coronal holes moving into the equatorial region here. Will they become trans-equatorial? Will they shrink? Will they produce geo-effective high-speed solar wind? We'll keep you posted on that too. Here's a visual of the growing coronal hole scenario there in the east central region there. South Pole oriented coronal holes right there. We'll be keeping an eye on them before they're keeping an eye on us. And when I say eye on, oh well, the pun is intentional. Also check out this little crown prominence. There is a crown prominence that we've been seeing on all the different wavelengths. Right there, you see a little bit of activity there. Likely on the far side of the sun. Anyway, continuing on. Yeah, so there was a solar flare that happened while we did show prep once again. A mid-level C-class flare, a low-level C-class flare, really. Let's blast through some more data. No spikes in the proton flux. No relativistic particles striking the Earth geospace at the moment. And let's take a look at the real-time solar wind here, requiring a refresh. There we go. There's some fairly current data. And so, yeah, if there is a CME strike in there, I'm not so sure. Looks like a high-speed coronal hole wind stream, a very weak one. But the main thing to note here was this moment right here, where we saw a total field of 14 nanotesla and a BZ of negative 12. That's a really strong South Pole oriented BZ component there. And that was the cause of the geomagnetic unrest and the geomagnetic storms, really. Anyway, density made it all the way up to about 40 protons per cubic centimeter there on the leading edge of this coronal hole wind stream. The high-speed portion looks like it's not even here yet, which we did see it uptick a little bit here. It made it up to about 423 kilometers per second. Don't be surprised to see additional high-speed pulses here, as this looks like it may be a continuing thing here. Anyway, fairly inconclusive data there, in my opinion, about coronal mass ejection strikes. So here's the KP index, a measurement of global geomagnetism, and you can see we did reach to a KP of, it was only a KP of 5. I thought it was a KP 6. KP 5 here. And if you remember yesterday on our daily space weather video, we looked at the data and I noted that the KP5 was going to, the KP4 was at least going to return. You can see after our premiere, it did indeed return. And that was because I was looking at the magnetism. Anyway, moving on. Here's 4 hours of geospace activity. It's our geospace magnetosphere movie, and we're seeing high pressure. Quite high pressure here over the past 4 hours. A little bit of a subsiding there in the second half of the geospace magnetosphere movie. Also fairly homogeneous pressure on both the bow shock and the magnetotail sides. Next, we'll look at ground magnetic perturbations, changes to Earth's own B field. Coming a little bit closer to home here. And we show it daily in that there is a polar excursion going on. Earth's south magnetic pole is someplace down here. And the north one is someplace over Siberia. Let us know in the comments if you're frightened of geomagnetic excursions. I'm not. Don't let that affect your fear. Anyway, that was 4 hours of data. Changes to Earth's B field, geospace delta B. Now let's take a look at the solar system space. Here's where stuff is now for all of our spaced out viewers. We'll advance this 1 week. There's where things will be on the 25th. Full moon coming up right close to the solstice. We'll be streaming live for the solstice, by the way, which happens around 3:20 p.m. on Wednesday, September 22nd. So here is a star chart from in-the-sky.org showing the ecliptic, the yellow line, and the galactic plane, the blue line. If you want to make yourself a star chart, head to in-the-sky.org. Today's cosmology segment is going to be brief and integrated to the daily space weather. We're not going to pick a random number at all. We're going to tell you about yesterday's cosmology segment. Yesterday's cosmology segment was one of the best ones we've made. We've got over 200 videos in the cosmology segments playlist. So check that out, youtube.com/smashamash/playlists. There are all kinds of playlists there besides the daily space weather. Here's a little tidbit from yesterday's cosmology segment. Well, there are the X-ray transients from Sagittarius A star. Oh, the X-ray transients from Sagittarius A star. Let's check out the astronomy picture of the day. It's spectacular. It's a very interesting galaxy in that it is significantly smaller than the Milky Way, yet it has a lot more stars. So this particular galaxy, you can find images of this. It's Rubin's galaxy, also known as UGC 2885. This one's, it's actually quite a lot bigger than the Milky Way. It's about 8 times the diameter of the Milky Way. And so there's a reason for it to have so many stars. Estimated to have around 1 trillion stars. Rubin's galaxy, a spectacular picture here. A great orientation, too, for a spiral galaxy, in that we're not looking directly across the disk. In other words, we're not viewing it edge on, and we're also not viewing it directly down the pole. Just a great orientation to see all the features, the dust lanes, the X-ray emitting regions, and the deep, deep gravitational well in the core. That's today's Cosmology segment. Again, check our playlists for lots more. Let's check charging hazards. We see some over places like Mexico, moving into the central Pacific Ocean. Oh, they've subsided. All right, I pressed refresh. Charging hazards now subsided. Here's a one-year chart of the relativistic electrons surrounding planet Earth. These are measured by the GOES 16 and 17, which are in a geosynchronous orbit. They're measuring the electron flux at the F ionosphere layer at around 300 kilometers of altitude. Here is the data from the GOES 16 and 17 over the past 3 days. Let's just keep pressing refresh and hoping for the best. Well, the 3-day chart wasn't coming through, so I just brought up the 1-day chart. It's only showing the GOES 16, and it's cratered here. That's a typical thing that we see during coronal hole wind streams. No real surprise there to our regular viewers. Here's the forecast, and we're going to expect to see a little uptick here in electrons in the coming days. No arguments there. Here's a diagram of Earth's Van Allen belts, because we're going to show you the total electron content forecast next. The total air column all the way up to a GPS satellite from your GPS handset. Most GPS errors occur around the equator at noon, and we're seeing a little bit of chaos here in the electron bands, which is a typical thing we see during coronal hole wind streams. Here's another diagram of the atmosphere showing you where the F ionosphere layer is located, because that's our next slide, the ionogram. And we're seeing some quite high frequency anomalies here. You're going to see it make it all the way up to 14 megahertz. That's 14 million vibrations per second. And some low frequency anomalies as well. So a huge range showing up here. And here's a latest image. That's from 10 o'clock Universal Time. You can see some major low frequency anomalies here around South America, North America, the Central Pacific, and some extreme high frequency anomalies around the Indian Ocean. Low frequency anomalies also around the Central Atlantic, showing up there in red, high frequency in blue. This is an anomaly from the 30-day median in megahertz. And there you can see mostly high frequency anomalies centered on the equator. That's 10 o'clock Universal Time. Do you watch our meteorology segments? Well, if you haven't, that's a playlist also, youtube.com/smashamash/playlists. Go watch all of our old videos. There's all kinds of content you may not be seeing if you're only tuning into the daily space weather. Bonus features. Make sure you check out our meteorology segments if you haven't checked those out. youtube.com/smashamash/playlists. Thanks to our BitChute subscribers. Thanks to our Twitch followers. Go follow us on Twitch if you haven't. They've got a great mobile app as well. It'll even tell you when we went live, like we just did to do today's meteorology segment. Thanks to our YouTube subscribers. If you're viewing the videos any place besides YouTube, go view them over on YouTube. In that, it's the source of most of our videos. So if you want to see most of the content, head to YouTube, press like, subscribe, press share. Share on Mark Zuckerberg's Facebook page. Also, thanks to our patrons. Most of all, thanks to the Smash team. Make sure you visit our websites if you haven't. You're all invited. Everybody watching this video, you're invited to the Smash team. Here's a tidbit. Let's move on. You can find links at smashamash.com. Smashamash.org will relocate you. And welcome to the Neo-Renaissance. Congratulations on realizing our channel and our web ring exists. Please support us via the links, becoming a Smash team member, etc. Let's check out the latest hydrogen alpha imagery here from El Teide, Spain. It's probably going to show us a coronal mass ejection happening associated with this solar flare, and indeed you can see some filamentary activity down here in the southeast. Coronal mass ejection warning continues. All eyes on that area in the southeast. So here's the latest intensitygram. Do we see a sunspot yet? Well, certainly not. We see some magnetic fields rising, though. So here's the latest in the colorized magnetogram. No sunspot yet. And here are some more images of this most recent coronal mass ejection, prominence, and solar flare. Great visuals here in 304 angstroms from the SDO. Here's a close-up in 171 angstroms. Noise. And we'll close things out in this composite imagery. This is 304 and 171 angstroms. Thanks for tuning in. Again, congratulations on realizing our channel exists, and may that solar wind be at your back.